Welcome to this episode of Real Chemistry. This is the first video in a series of 3 videos all on balancing redox reactions. Balancing redox reactions can be a pain, and it depends on the conditions under which your redox reactions are occurring. So there's going to be 3 videos. One, when you're balancing a redox reaction under neutral conditions. A second, where we're looking at acidic conditions, and lastly, where you're looking at basic conditions. So this is the best video to start with to think about how we're going to balance these redox reactions, which is different from balancing a standard reaction. Remember that a redox reaction is one where electrons are being exchanged. And so if I look at this reaction below, it has one aluminum on this side and one aluminum on the right. So when we just think about balancing chemical species on left and right, that's already balanced. One copper, we're good, right? Except, if I look at the charge of copper, it's 2 plus over here, and the charge of aluminum is 3 plus over there. So that's not balanced. There's actually more electrons on the left side of the reaction than there are on the right. And so balancing redox reactions is all about balancing the number of electrons used up on one side and given to the other side. And so what we need to do is follow a special set of steps to make sure that the number of electrons are equal before and after. All right, so let's go through these steps. The list of steps are starting out simple. So neutral solutions are the easiest. Acidic conditions are a little harder. Basic conditions are the hardest. So this is going to be your simplest set of steps, and then you'll see that it builds from here. So the first thing we want to do is we're going to split it into what's called half reactions. And what we do there is we just divide it by element. So we're going to take the aluminum reaction and split it apart from the copper reaction. And this is a standard thing to do in redox chemistry and electrochemistry because all of these different half reactions can be put into a table with their voltage, things like that, their reduction potential. And so here we're going to split it into the aluminum half and the copper half, and we're going to think about them separately, and then at the end we'll put them back together. So first, let's split them in half. So we're going to write one reaction where we have aluminum going to aluminum 3 plus. So when I split it in half, I just look for the element on the left and the element on the right, and I bring them down without anything else. So the neutral is on the left and the 3 plus is on the right. Now I bring down my copper. So I bring down copper 2 plus, has to be on the left because that's what's on the left here, and copper on the right because that's what's on the right there. All right, so that's splitting into half reactions. Second part, balance the charge with electrons. Notice, on this side I have plus 3, and on this side I have neutral. So how can I make those the same? Well, when I add electrons, I'm going to make that side more negative. So what you're always going to do is figure out the charge on both sides, and you're going to add electrons to the more positive side. Add electrons to the more positive side. So here I have plus 3, and here I have 0. So I need to add 3 electrons on the side with aluminum 3 plus. Now that makes my right side, my products, 3 plus and 3 minus. That gives me 0. And my aluminum on the left is already 0, so now they're balanced. Same thing here, 2 plus and 0, because this copper, right, has a 0 charge. Well, I want to put extra electrons on the more positive side to make them balance out. And I need 2 electrons on this side. You should always see that you add electrons on opposite sides of these half reactions, because you need to be giving up electrons from one element and gaining them on another, in order for it to be a redox reaction where you're exchanging electrons. So that was step 2. Now, step 3, find common multiple of electrons. So when I'm running redox reactions, one of my elements is giving up electrons, the other one's gaining. Those numbers have to be equal. Just like if I pay you for something, if I give you $5, you're going to gain $5, right? If this aluminum gives up 3 electrons, copper has to gain 3 electrons. Well, they're not balanced right now. And what that means is we have to figure out how many aluminums have to react to give up enough electrons that copper gains the correct amount of electrons. And very often what it turns out to be is that you multiply the top reaction by the bottom number of electrons. So this one times 2, 3 times 2 is going to give me 6. And this one times 3. 3 times 2 is also going to give me 6. So we just want to make the numbers of electrons on each side the same. Now I'm going to rewrite my reactions down here. So first we'll rewrite the aluminum. 2 aluminum, that's because we multiplied the whole thing by 2. Goes to 2 aluminum 3 plus 3 times 3, or 2 times 3 electrons gives me 6 electrons. Now I'm going to rewrite my copper half reaction. 6 electrons plus 3 copper 2 plus goes to 3 copper neutral. Now, last step, I'm going to add them up to get my final reaction. My electrons cancel out. I gave up 6 electrons up here, and I gained the 6 electrons down there. And when I write my new reaction, I'm just going to bring down my reactants, 2 aluminum plus 3 copper, 2 plus, goes to 2 aluminum, 3 plus, that's one of my products, and my other copper, plus 3 coppers. Now notice my charges balance out, because I have 3 coppers at 2 plus, that gives me plus 6. Over here I have 2 aluminums at 3 plus, that gives me 6 plus. So now my reaction has been balanced, both in terms of charge and elements. So that's balancing a redox reaction. Now, the next video you should take a look at is balancing them in acidic conditions, which is a little tougher. Thanks for watching this episode.